Okay, now these are the most talked about fatty acids, both particularly from a nutritional perspective, the omegas. I want to talk about that one first. Now, fatty acids can either be saturated or unsaturated. The word in the street is, from a nutritional standpoint, the saturated fatty acids, or triglycerides, are the most unhealthy for you. In fact, I just got my lab results back yesterday from my blood test. I have 3 spots on my arm from the blood test. I don't understand why there's 3, but anyway, and my A1C is high. It's not real high, but it's just over the border of normal. So the nutritionist sent me this big long list of what things not to eat. Saturated fats is on there. I said, well, I don't eat saturated fats. In fact, I eat very little. Stay away from carbs. I don't eat very many carbs either. So anyway, all right. So let's talk about these. Let's talk about the saturated ones first. Okay, the one that you get in beef, pork, and lamb that's particularly unhealthy is called stearic acid. It's abbreviated SA, and it's 18 carbon acid, organic acid. Now, to name it, it's called octadecanoic acid. Octa meaning 8, deca 10, so that's 8 plus 10 is 18. So octadecanoic acid is stearic acid, common name, abbreviation is SA. Now, the way biochemists label these acids, other than calling it octadecanoic acid, they use this delta symbol. If there's a double bond. Well, stearic acid and palmitic acid, neither one of them have a double bond. So there's no delta with it. But what they do is that they go 18, meaning 18 carbons, colon, and then the number of double bonds. In this case, 0. Now, if there's a double bond, like for example, down here, there's going to be a delta, and that delta says what carbon the double bond is on, starting with the acetic being carbon number 1. The omega designation is from the end carbon, where is the double bond? Now, again, nutritionists use the omega, like omega-3s are the big deal for healthy fat. And you get that from fish and flax. In fact, this weekend I had tapas with some friends of mine, and we were making them. And I made one tapa with sardines. Sardines are a very inexpensive source for omega-3. And if you buy the skinless, boneless versions, they're extremely mild as well. You don't even know you're eating fish. And they're like $2.50 a can, and that's 2 meals, so pretty cheap. It's also really good if you have pets. They also love that. Also, they're packed in vegetable oil, or you can get them packed in water. I always get the vegetable oil because I use the oil because it's flavored. I use the oil for cooking. Also, my dogs love it to put on their dog food. So they're really good stuff. Cheapest place to get it is Costco. Okay, so, and the other version of the saturated fat that's in beef, pork, lamb is palmitic acid, and it's a 16 carbon saturated fat. And so that's 16 colon 0, no delta because there's no double bonds, and omega 0 for the same reason, no double bonds. Its abbreviation is PA. Palmitic acid. Now, frequently, some of the meat you eat has only these two fatty acids, and they're tied up in a triglyceride. They're not alone. They're always tied up with a triglyceride. Okay, so let's look at some unsaturated fatty acids. The quote unquote healthy one is oleic acid. And it gets its common name from olive. And that's where it was first discovered, in olives, hence the name oleic acid. Okay, so its formal name is 9. That's the position of the double bond from this end here. That's carbon number 1. This would be carbon 18 down here. So looking at the biochemist way using the delta, so it's 18 carbons long, 1 double bond, and it's at position number 9 from the acid end. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9. It's also an omega 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Trioleate is the name of the triglyceride. Now, again, there's 2 kinds of vegetable oils: seed oils and non-seed oils. Huge difference health-wise. Oleic acids are not processed much. Seed oils are highly processed. That's the problem with seed oils. And I'm talking about like soybean oil, corn oil. Those are all seed oils that basically come from vegetables, typically grain-like vegetables. Okay, to name it, octadecanoic, since it's got a double bond in it, at position number 9, acid. You might ask yourself is, it could be one of 2 forms. It could be cis or trans. So we have to label this. In the configuration I have up here at the top, it would be cis 9-octadecanoic acid. Okay? Do those make sense? Okay, so let's go. Okay, a very common omega-3 fatty acid is linolenic acid. And it's an omega-3, 1, 2, 3 from the end. It doesn't say where the other 2 double bonds are. That's the problem with the omega. It just says, where's the first one? All it says, where's the first one? Now, it's got 3 double bonds. So biochemists go, well, that's 18,3 delta 9, 12, 15 from here. So this would be 9, 12, 15. The IUPAC way of naming this would be octadeca 9, 12, 15 trienoic acid. Tri meaning 3. So you have to have 3 numbers that correspond to the tri part. And you can also have the salt of an acid. For example, this can be a sodium salt of that acid, which would be sodium. Octadecy 912 trienoate. You're going to have the acid that has the proton on it. You can have it without the proton in the salt form. You need to be able to name it both ways. Also note, this is the alpha form of the linolenic acid. As there's another form of linolenic acid, which has got 3 double bonds in it, but it's not an omega-3, it's an omega-6. So the double bonds, the 3 double bonds are in different places. Arachidonic acid, ARA, is a very important fatty acid because it's a precursor to a whole bunch of other things. For example, precursor to prostaglandins. Prostaglandins make painkillers, they clot blood, a whole bunch of things. So it's important to get some of this in your system. Now, this is not an omega-3, it's an omega-6. Okay, so to name it, Icosa means 20. So we've got Icosa 5, 8, 11, 14, tetraenoic acid. Okay, so tetra is 4. And let's see, we have 1. So we have position 5, 8, 11, 14. Now, they're always 3 carbons apart. And the reason why they're always 3 carbons apart is the way animals make fatty acids without eating them. And it makes it by 2s. That's why also all the fatty that's why all the fatty acids are in even numbers rather than odd and even. Now this has got 4 cis double bonds. So we need to say cis, 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 cis. I don't have room to write out the cis. Because it could be cis, trans, cis, trans. And let's see, said everything. Oh, the abbreviation is ARA. Okay, linoleic acid on the right is an extremely common fatty acid found in your seed oils. Again, corn oil, cottonseed oil, soybean oil, etc. Yeah.
What does the number on the omega mean?
It's the number from the end where the double bond starts. For example, going back to Eric, well, let's go over to linoleic, okay? So here's position 1, that's 18. So omega-6 means 6 in from the end, the first double bond starts. So we go 1, 2, 3, 4, 5, 6. Correct. So they start from each end. The delta starts from the acid end. The omega, think of the omega is the last letter of the Greek alphabet. So that's an easy way to remember. It's also the last carbon in the acid. Does that make sense?
Yeah.
Okay. So it's an omega-6. That means 6 in from the end. Common name is linoleic acid, La. The IUPAC name is going to be octa deca, that's 18, 8 plus 10, octadeca dienoic acid in positions 9 and 12. Or if it was a sodium salt, which we made last week, 2 weeks ago, we made soap, that would be octadecy 912 dienoate. So potassium or sodium OHs are salts. They're also esters, OHs. Okay, and it's an omega-6, so it's not particularly healthy, but it's really cheap. And frequently, it's not non-GMO. In the United States, it's virtually impossible to get pure, non-genetically modified corn because we plant so much of it in this country that's modified. And there's something called wind that spreads the pollen to every field nearby. So if you have an organic field, it gets pollinated as well. The only way you can grow non-genetically modified corn is in a greenhouse, which is a lot more expensive than in a field that's watered for free from the rain. So it's a real problem. If you want to stay away from GMO stuff, genetically modified organism, GMO, don't eat corn or use corn oil. This can't happen. And more stuff is being ratified by the Food and Drug Administration, particularly with the current political group we have in the office. They want to get rid of as many regulations as possible, one of them being labeling foods. Labeling foods is a good thing. That's how we know there's no trans fats and stuff because of food labeling. Okay, so linoleic acid, bad from a health perspective. Okay, so let's go on here. All right, the next one, frequently when you buy omega-3 fatty acid, you get 3 of them. You get EPA, DHA, and ALA. And frequently, you won't get arachidonic because it's not omega-3. So you'll get those 3 in your little bottle of omega-3s, or eat more healthy. Okay, so let's look at DHA. 22 carbons long, 6 double bonds, 6 cis double bonds. It's an omega-3. So that means so 3 carbons in from the end is the first double bond, and it doesn't say anything more about where those other double bonds are located. Using the delta, we do know where they are located at, or if we know at the IUPAC name, we also know where they're located. So docosahexaenoic acid. Docosa 4, 7, 10, 13, 16, 19 hexaenoic acid. Kind of a mouthful. Okay, 22 carbons long, 6 double bonds at positions 4, 7, 10, 13, 16, and 19. And again, abbreviation is DHA. Normally, you won't see the name, you just see DHA, unless you look in 2-point font bottle. The other common one that DHA is EPA. Think of the P is the penta, the H in the DHA is hexa. That's one way that I remember how many double bonds are in each one of them. Okay, so, and this would be 6 cis. Over here on the right, the icosapentaenoic acid is 20 carbons long. So this stands for 22. Icosa, it stands for 20. Again. And again, it's going to be 5 cis's here. Okay, so it's going to be cis. Icosa 5, 8, 11, 14, 17. Pentaenoic acid. Okay, the penta is 5 And you have to have 5 numbers that correspond to each one of the pentas. And it's abbreviated EPA. Okay, so those are extremely important fatty acids. From a nutritional perspective, a chemical perspective. Okay, are there any names about, any questions about how we name those or anything like that? Okay, let's see, the other thing I wanted to go over in more detail is naming again. So if we go back to here. This is the first day we covered acids and esters. Remember, with an ester, you've got a secondary and primary backbone. On Thursday, it's going to be a big review session. I'm going to talk about reactions, both reactions, single step and multi-step reactions, because we didn't get to those much in test 2. Test 3 is going to have a fair amount of reactions. Okay, so I want to talk about naming though here. Naming here. So naming an ester. Okay, an ester is made up of an acid and an alcohol. You name the alcohol first, and the alcohol is considered the secondary. The acid part is the primary backbone. Just like with acetals and ketals, you have primary and secondary backbones. Now we're going to see in the next unit is going to be on nitrogen combining with an acid. You're going to have a secondary primary backbone again. Only it gets more complicated because you can have multiple secondary backbones, up to 3. Actually, you can have, in a special case, up to 4, but mainly 3 secondary backbones. So it's important to be able to recognize primary versus secondary backbones for 2 reasons. One, in naming, and also for reactions. Okay, so let's get into naming these guys. Okay, with esters naming, you always name the alcohol part first. So in this case, it is a 2-carbon, a 1-carbon alcohol. It starts from a 1 carbon alcohol. So that's going to be a methyl group. So it's going to be methyl. And then you name, this is a 2-carbon acid, primary alcohol. See, when you can't park, what happens? You can't talk right. A 2-carbon acid start. So that would be ethanoate. Now the noate indicates one of 2 things, an ester or a salt. Ester or salt. What I mean by salt is that means the H came off the acid. So it's going to be sodium or potassium. And it's going to be a blah, blah, blah in the carbon backbone in the middle, noate. with an ester, it's in two parts. You have the alcohol part named first. Second part is going to be the acid part. So in this case, it's a two carbon acid, one carbon alcohol. So it's going to be methyl. So that's the one carbon part. Secondary backbone, ethanoate. Okay. So the NOATE, when we're talking about esters, just signifies it's an ester, naming wise. Okay. So if it's an aromatic ester, depends where that aromaticity comes from. The aromaticity usually is a phenol name. So in this case, it started off with phenol, the aromatic acid. So you're going to start by starting off the name with phenol. And this is a four carbon acid primary backbone. So it's going to be phenyl butanoate. Butanoate. Okay, this one here. This is also an aromatic ester, but the acid base starts from benzoic acid. So that means it's going to be a benzoate. Because it's a two carbon alcohol start, it's called ethyl benzoate. Now, when we get to unit 4, it's going to be the same thing. You're going to have an acid plus an amino group. And so the amino group is going to be the secondary backbone, and it goes first. Same thing. Okay, is there any questions about naming these esters? It's just a matter of practice. Now, we go to Canvas files, unit 3. I have worksheets for you to practice. And this is a pretty long one. It's got now some of these are going to be you actually draw stuff or name stuff, and some of them are also multiple choice. For example, this one is multiple choice, but there's still a lot of practice. This is a long one too. So again, I want to give you as much opportunity as possible to practice. Okay, these are where the slides I use, by the way, are located. Most of you probably found that by now, but just if you haven't, this is where they're located. And there is a corresponding flow chart for the reactions. So, I'll always give you that for tests. That's not going to change. Um, this one's got it all together in units 1, 2, and 3. That gets complicated. Um, let's see. So are there any questions about where you can practice worksheets, naming, anything like that? Okay, so let's spend another 15 minutes or so and go over some reactions. Okay, so let's name this guy. Okay, right away. Right away, you know two things. One, an acid base. The salt. So you have acid and salt together. Okay, so it's a sodium and okay, it's got no secondary backbone because it's not an ester, but it's got a primary one. So which is it? Well, let's see here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. The longest chain is 6, so it's going to be a hexa. And it's going to have a branch. If it's a salt, it's going to be a noate, sodium noate. Okay. And we've got a branch at carbon number 2, and that is a 1, 2, 3. So a propyl branch on carbon number 2, hexanoate. So sodium 2-propyl hexanoate. Okay, that makes sense. So boom. As soon as you see the sodium or potassium, it's a salt. So just write that down. Boom. And you already know the ending because that's going to be a noate. Then identify your backbone and then any branches off the backbone. Okay. That would be how I'd suggest you approach these. Okay. Looking at this guy here, with the OCO, double bonded CO in there, we know it's an ester. So it's also going to have a noate ending. Okay, so what's the primary backbone? It's going to be benzoate because it starts with benzoic acid. And that's a 2-carbon alcohol. So we're going to start with ethyl. Two-carbon alcohol start. And then because it's derived from benzoic acid, it's going to be benzo. I'm going to drop the N. So it's benzoate. Benzoate. You drop the N only with benzoate. Everything else has got a noate because it comes from the noic acid part of the acid from which you start. Okay. So it's ethyl benzoate. So this is a aromatic acid, 2-carbon alcohol. Again, we have OCO. We have an ester. So identify the primary backbone and secondary backbone. Now, don't get into the habit of always writing esters with the alcohol part on the right side. Doesn't matter where it is. This thing can be done vertically as well. Okay, so this is going to be the alcohol part corresponding acid part. So we've got 1, 2, 3, 4, 5 in backbone and a 2-carbon secondary backbone. Okay, so 2 carbons means it's going to be ethyl. And it's based on a 5-carbon acid. So that's going to be a pentanoate. So this comes from a 2-carbon alcohol, 5-carbon acid. No branching. So right away you're saying, whoa, I'm going to name this guy. Well, you can name it a couple different ways. First of all, you need to know what is it. Okay, one, it's an acid. And it's a long acid with a lot of cis double bonds in it. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it's one of the 20 carbon acids. COSA. And there are 1, 2, 3, 4, 5 cis double bonds at positions 5, 18, 11, 14, 17 from the acid end. Notice they're 3 apart. So if you start with the first one, just add 3 each time. So it's icosa 5, 8, 11, 14, 17 pentaenoic acid. Or this is the sodium salt, then it would be sodium CCCC5 cisses, icosa 5, 8, 11, 14, 17 pentaenoate. Okay. All right, good old acetic acid. Two carbon ethanoic acid or acetic acid. You draw the following. Okay, so let's draw some of these. Okay, so we know it's an acid. It's an enoic acid, meaning it's got some double bonds in it. And in this case, it has 1 double bond. Now, you could also say 1 hexa monoenoic acid also. If it's 2 or more, you've got to do it like we name these guys up here. We put the okay, so we've got it's a 6 carbon acid with 1 double bond at position number 1. Let's draw this the way it's written. Okay, so 6 carbons long, right? And let's draw it using the line here. We have 6 carbons. 1, 2, 3, 4, 5, 6. And we've got a branch, 2 branches. At 1, 2, 3, and 4. Okay. So if you saw this structure here, okay, that says it's at a double bond at carbon number 1. Okay, so if you saw this structure, what would you do? say Ferguson, there's something wrong. Two things are wrong. First of all, how many bonds is carbon supposed to have? Four. Four. This carbon here has got 1, 2, 3, 4, 5. So this is an invalid or a non-legal structure. If I was to rewrite this, I would say something like three, 4-dimethyl 2-hexanoic acid. Okay, so that now 6 carbons long acid. 1, 2, 3, 4, 5, 6. And the double bond is position number 2, right here. And we have positions 3, 1, 2, 3, and 4. Let's see, let's redraw this here. Correct one. So this is bad. And this is an old test that I would have told everyone at the beginning. There's an error on problem 7, correct it. Or maybe one of his students. If you find an error on any of my tests, please come up and tell me. I'll give you extra credit for finding it. Okay? And I'll tell the rest of the class. But don't just assume. There's a way to make tests, for example, on draw the following. I would go through and just kind of change the branches and I changed the numbering. So probably before I made this was probably like an ethyl. So that's why it's separate from the methyl. Anyway, so just tell me, this isn't right, you know? Or at least if it is right, I'll just say, no, it's correct as written. Okay. So as soon as I see sodium or potassium, boom, it's a salt. Right away, we're going to have a K over here. And bentonite. Okay, that means that's a 4-carbon acid backbone. So 1, 2, 3, 4. And carbon number 2, we have a methyl branch. So that would be potassium 2-methyl bentonate. Okay. O8. That means it's a salt or ester, but it starts with methyl. So that means it's going to be an ester. So this is going to be the acid part. And this is going to be the alcohol part. With a branch on the benzoic acid at carbon number 2. So that's the acid part. And this would be the Um, well, okay, ICOSA? Yeah,
For number 8, what is the potassium?
what about,
Or you just lose? There's like no bond to it?
there's no, say your question again?
Does it connect to anything or do we just write it next to it?
Oh, there, it's ionic, so there's. Whenever you write ionic compound, you write them separately. They're not, an ionic bond is not. There's, different kinds of bonds. There's ionic bonds, covalent, polar covalent, and then pure covalent. So there's all these different kinds of bonds. Ionic bonds, electrons are being transferred. In this case, the electron is being transferred from the potassium over to that. That's why, actually, should be like this. Up there. So and it actually goes back and forth, resonates back and forth. Normally you don't write the resonance structure. You just write on one carbon or the other. But anyway, they're written separately. Sometimes you'll see square brackets. Like if you're writing a Lewis diagram, you'd write them separately with square brackets around it. So did that answer your question? Okay. Okay, so back to this Icosa pentanoic acid. Okay, EPA. So it's a delta that's 20 carbons long, 5 double bonds. Now, how do you know where the double bonds are? Okay, so I would suggest drawing your acid first. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so we have 5 double bonds. Now this is a omega-3. So you know that 3 in from the end is a double bond. 1, 2, 3. Now Icosa pentanoic acid is a omega-3 and it's all cis. So we just drew a trans double bond. So what we're going to do is we're going to put the trans in and switch it over to the cis afterwards. But you can also write it as all trans because I didn't say what it is on the Icosa pentanoic acid. I just said draw it. So you can draw them all trans or you can alternate cis trans. It really doesn't matter. But if it's EPA, it's all cis. Okay. So now we're going to alternate. Okay, so we have the 5 double bonds. So the delta on this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. 12, 15, 18, and 21. It's counting from the acid end. So we go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Two, 3, 4, 5, 6, 7, 8, 9. 10, 11. It should be 11. Well, 13, 15, and 15, 16, 17. Now, if I said, oh shoot, so if I told you it was EPA, then you just draw this. But if I didn't say EPA and it just said Icosa, that's just 20 pentaenoic acids, you wouldn't really know where the 5 double bonds are. But with specifically EPA, one is an omega-3 at those specific locations. Okay. So there are many pentaenoic acids. EPA is an omega-3 one. And it's also cis. Oh, 5 cis. Okay. Okay, the rest of these are going to be reactions, and I want to cover those on Thursday. Okay. Any questions about what we've gone over so far in the naming? Okay.